All right, so in this section, we're going to basically talk about Laplace transform properties. There's some properties of the Laplace transform that are important that we need to take a look at that will show up as we are solving problems and solving these circuits using the Laplace transform, and also some pairs of Laplace transforms that are going to be useful for us. Okay, so we'll talk about the difference between the two of those things. Actually, let me just take the chance to talk about that right now. So when I say Laplace transform properties, I basically mean if I take the Laplace transform of some particular function of t, let's just call it f of t, there's basically some kind of a change that's going to happen to that function of t, right? And it's going to become some function of s. But there are certain types of functions of t that will basically result in certain types of functions of s. So for example, let's say instead of f of t, we take the Laplace transform of f of 2t. Same function, but instead of passing in a value t, we're passing in 2 times t. There's going to be some particular, in this case it would be a half times f of s over 2. There's some particular mapping of multiplying t by 2 in the argument here that maps to the function in the S domain. Okay, so that's properties of the Laplace transform. It's not saying some particular function of t becomes some particular function of s. It's saying if we do something to that function of t, whether it's scaling the function itself or doing something to the argument like multiplying t by 2, then we can divide our function of s by 2 and also divide s itself by 2. That's an example of a property. That's actually the time scaling property, or scaling time by a factor of 2, and we'll show that in this, but I wanted to talk about that as just so I can make the distinction between properties and pairs. Properties are what I just mentioned previously, and we'll talk about those, but pairs are some particular function of t has some particular Laplace transform function of s that's unique. Okay, so different functions have different unique functions in the S domain when we take the Laplace transform. And we're going to look at some of those pairs. For example, we already saw that u of t becomes 1 over s in the S domain. Okay, so a function u of t, when we take the Laplace transform of that, becomes 1 over s. We already saw that the cosine of omega t times u of t becomes s over s squared plus omega squared in the S domain. These are examples of pairs, okay? And so let's go on to our first property here, the time scaling property, which I talked about. So we have basically the property here, and we have a description of the property here. It says if we stretch the time axis by a factor a, right? So we're taking our time axis, t, and multiplying it by a. This corresponds to shrinking the shrinking the s-axis by a, and the amplitude of f of s by a as well. And so we can see that here. We're basically saying if I had some function, f of t, and instead of passing in t, I pass in a times t, then the corresponding f of s would be divided by a, and the argument would also be divided by a. And so that is a property of the Laplace transform called time scaling. You don't need to memorize any of this. This is all going to be in the Laplace transform properties table that I'm going to give. Properties table. And again, this stuff's going to become really relevant when you take EE360 because you're going to learn more about these properties, and I just want to introduce you to them right now and show you what these properties are because they're important for solving these kinds of problems. And yeah, so I'm going to wrap this video up on time scaling. Again, it's just saying that if we scale our time by a factor of a, then in the S domain, that function that we came up with is going to be divided by a factor of a, and the argument is also going to be divided by a factor, that same factor, okay? So we'll look at the Laplace transform properties. Again, you don't have to memorize this, but just want to introduce each of these important, there's 5 really important Laplace transform properties. Time scaling is the first. We're going to look at 2 more in the next video, and then 2 more in the video after that. So I'll end this video here, and we'll see you guys in the next video.